Okay, so let's start. Just to reconfirm, am I audible? Okay, then let's start. So this is week number 4, that is on 17th of Feb. So I hope you've had a very nice Valentine slash Shivratri weekend. This week was all about standard distributions, right? And there is no strict definition for what is a standard definite distribution, because the standard is a very ambiguous term, but what it means is that some kinds of distributions which occur again and again in these kinds of courses. So we had three kinds of them. So sorry, two: discrete and continuous. So in discrete, we learned first about, I guess the uniform one was the first one. Let me check. First is constant here, which is that probability of x is equal to alpha is 1. So x can take only one value, which is alpha. In a very strict sense, it's not even a random variable per se, right? Because there is no randomness here. X has to be alpha. Only alpha can be the correct value for x. So there is no uncertainty in x. Second is Bernoulli, for which x can take two values. Traditionally, they are taken to be 1 and 0. And so one has to be complement of the other. So x is equal to 1 is treated as some kind of success, yeah, some positive thing which has some probability p, and the x is equal to 0, the failure has probability 1 minus p. Naturally p has to be between 0 and 1. It could be 0 or 1 as well, but that it's same as constant, so we don't call it Bernoulli. That's why p has to be strictly between 0 and 1. And the third one was binomial. And binomial distribution means that you have n boxes, yeah, n boxes, and each can have success or failure, right? So you can either have p or 1 minus p probability here, p or 1 minus p probability here, and then you ask probability that there are number of successes is x. So let's say success means victory for India. These are the cricket matches of India. So out of n games, how many games does India win? That's a random variable, right? And the winning probability is p. So uh, and we ask that what is the probability that India wins x games out of n? So naturally x has to be between 0 and n, right? So the probability is that first we can choose uh, x boxes out of n. So now that we have chosen these x boxes, maybe this and this, then those x boxes should have success. So each should have p, 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 and the remaining ones should have 1 minus p. So that is 1 minus p raised to n minus x. Okay, so this is the probability of x. So this is our binomial distribution. And note one interesting thing is that if xi is Bernoulli distribution, let me write BERN, with success probability as p, then sum over xi, I is equal to 1 to n, would be binomial. Same logic. With n elements, and p probability. Okay, so that's that. Then the fourth one was geometric, which is when probability of x is 1 minus p raised to x minus 1 times p. X is equal to 1, 2, 3, etc. Okay, which is the same as saying that x is the first time success is achieved. So if I ask that what is the probability that the first victory for India occurs in its seventh game? So that same as saying that India loses 6 games. Then the probability of losing is 1 minus p. So it would be 1 minus p raised to 6. Right? X is 7. So this is 7 minus 1. So it has to lose the first 6 games and it has to win the seventh game, which is why it's followed by this p. Okay. And for each of them, you can write expectation and variance, etc. Then the fifth one was negative binomial. Better word is Pascal. I really don't understand why it's called negative binomial. If you know, then let me know. But yeah, the distribution is given by x minus 1 c r minus 1 p raised to r 1 minus p x minus r, where x could be r plus 1, etc. So it's a obviously it depends on r as well, and the interpretation is that x is the first time rth success is achieved. All right. So if you put r is equal to 1, then it's nothing but geometric. All right. And the next one is Poissonian one. It's an interesting thing because it looks very weird. Let me just write the expression for it. P of x is equal to x is e raised to minus lambda raised to x over x factorial. Okay, so there is factorial and everything, and again lambda is parameter. So what does it indicate? If you study stochastic processes or any kinds of processes in future, you might encounter this. So I will just give you intuition. Let's say this is our time axis, and there are some events that are happening. It could be anything like nuclear bombs go blasting, or supernovas in the sky, or bus coming at your bus station, etc. Or if you are commuting by auto, then auto is coming. So let's say uh, auto is coming. Sorry, this is a very bad auto, but let's say it came at t0. Then the next time it will come at some other time t1. All right, etc. So then it comes at t2, etc. So are they uniformly spaced or no? That is the first question. And we might think that they should be uniformly spaced, right? Because they don't care about each other. We are assuming that they are coming independently, but that is certainly not the case. In fact, if you think about it, if you must have observed this, sometimes there are lots of autos or lots of buses, and then there are times where there are no buses. Okay, and that happens because the distribution is Poissonian. So if we assume that in any given delta t, where delta t is very small, so probability that auto comes in t to t plus delta t is constant times delta t. Okay, so lambda times delta t, and then you ask probability that between some t1 to t2 n autos arrive, and what you will find is that this is a Poissonian distributor. Okay, with this parameter lambda, and obviously it depends on t1 and t2 also. I don't remember the exact formula, but Poissonian looks something like this. So you have initial peak and then it goes down, right? So this is T of n versus n. So there is a maxima here, and the average, or rather the mean, is equal to 1 over lambda. So mean time that you will have to wait is 1 by lambda. What it means is that this is why sometimes you see lots of autos, because the maxima is at some small values, but sometimes it happens that there is a large time before the next auto comes. Okay, so they are not uniformly scattered. In fact, if you look at the distribution of time interval between two autos arriving or between two supernova blasting, then this time is distributed exponentially with the same parameter lambda. All right, because now this time is a continuous variable, and the Poissonian process, that is the number of autos that come, which is a discrete number, that would follow this Poissonian. So this Poissonian variable and exponential random variable, they are very intimately connected. All right, and the final one, which I thought would be the first one in the list, but apparently not so, is the uniform random variable. So you have some values x1, x2 up to xn, all have same probability. All right, and total probability has to be 1, which means that each of them has probability 1 over n. All right, so probability that x is equal to x is equal to 1 over n if x is equal to x1 or x2, etc., or xn, and 0 otherwise. Okay, so this is the uniform distribution. Any questions so far? Okay, then let's go to continuous one. In that, uniform. Okay, the previous one was also uniform, but in discrete random variable. Now we have a continuous random variable. So we have x, and our x is uniformly distributed between 2 points. So you can think there is a road of mass 1. So what is the density of that road? Well, total mass is 1. So it was denoted by fx here. So the density would be 1 over the length of this road, or length of this interval, which is b minus a, right? And that is only if x belongs to a to b, right? Otherwise it's 0. So this is our f of x. What it means is that you have equal chance of being anywhere between this. There is no preference towards b or towards a or in the middle. All right. And naturally we can ask what is the mean, and as you can see, because it's symmetric, the central value, which is a plus b by 2, that has to be mean, and variance you can calculate, that comes out to be L square by 12, where L is this length, L is b minus a. Okay, and the second one is exponential distribution. which is given by this PDF lambda e raised to minus lambda x greater than 0. Okay, and 0 else. So the graph would look something like this. Starts with lambda and it goes down exponentially. Okay, and this has one important property, which is that it's Gajni, memoryless. It doesn't remember what happened in the past. And the correct statement to make is this one. Probability that x is greater than t plus s, given that x is greater than s, is same as probability that x is greater than t. Okay, so what it means is that on this line, let's say this is s, and then we go move ahead t units. So s plus t. So given that we are on this line, the probability that we would be on this line is same as if we shift everything to 0. Okay, so s is shifted to 0. So s plus t would be shifted to t, right? We are moving t units. And now, obviously, probability of that being greater than 0 is 1. Yeah, because it takes only positive values. And the probability that s is greater than t is whatever it is. So what this is saying is that we can just shift this distribution, entire thing, which means that it really doesn't care where exactly that is happening in the time. In other words, it's memoryless. Okay. It's also called Markovian. So fancy people call it Markovian process. Okay. Which is why Poisson distribution also occurs in most Markovian process. Poisson, by the way, was a French mathematician, and like many other French mathematician, I think his name is also engraved on Eiffel Tower. Okay, third one. Now the more convoluted ones. One is gamma, for which the distribution is given by lambda raised to r, x raised to r minus 1, e raised to minus lambda x divided by gamma of r. Okay, and this gamma of r must be defined, and that is defined as 0 to infinity t raised to r minus 1 e raised to minus t dt. And you might think why we are defining it like that, and the answer is that this is actually the definition of r minus 1 factorial. Okay, so if r is an integer or rather natural number, then you can compute this and you will get r minus 1 factorial, but now r can be any number. So this is a natural extension of factorial function. Okay, so let's say we are plotting n factorial versus n. So we know that 0 factorial is 1, 1 factorial is also 1, 2 factorial is 2, 3 factorial is 6, etc. Right? So we now want a continuous curve which goes from all these points, not just this one, but also for any natural number. For 100, it should go through 100 factorial, and it is this curve, gamma of r. Okay. Um, yeah, and you can reduce it to the other distribution like exponential 1 if r is 1, etc. Okay, and the fourth one was beta distribution. Again, we can cook up any distribution, but we are studying this one because these are actually the ones that will come up in the course. and which is why they are very important. Okay, so it's given by x to the power alpha minus 1 and 1 minus x to the power beta minus 1, and that is defined only between 0 and 1. And then you have some normalization constant, which, as you can guess, has to be integral uh, of the numerator so that the total probability is 1. So it is literally the integration of what is upstairs. Okay, and you can in fact solve this. This turns out to be gamma of alpha, gamma of beta divided by gamma of alpha plus beta. All right. Finally, I think this is the last one. Yeah, no, second last one. Cauchy f of x is equal to 1 by pi beta 1 by 1 plus x minus alpha divided by beta square. This is a very cool kind of distribution because it does not have mean. Okay, so it does not exist. Why? Because integral of mod x fx goes to infinity. So this is the reason. In particular, fx, if I choose beta to be 1 and the mean alpha to be, not the mean but central value to be 0, then I get this one, which is also called Lorentzian. Okay, so these are something called heavy tail distributions, because unlike the normal distribution that we'll study next, this has very high probability of having very high value. Okay, finally, the most important, it's called normal distribution. It's also called Gaussian. For some reason, the professor doesn't like this term, but at least in literature that I have reviewed, this term also appears a lot. F of x is 1 by sigma square root of 2 pi and exponential of x minus mu square divided by 2 sigma square. And in fact, we can plot this and see what this means. Okay, so let me do that quickly. So you can also do this at your home. So there is something called Desmos. I talked about this. So go to this website, open graphing calculator, and you can graph anything. Okay, so we have to plot this normal curve. 1 divided by, it was sigma times 2 root pi. So let me call sigma as s and then square root of 2 pi times exponential. So e raised to something, that something is minus x minus mu square. Instead of mu, I'll use m, and it should be square but outside. So m square and divided by 2 sigma square. So again, s square, and s and m are parameters, so I can add sliders to this. Alright, so yeah, for m is equal to 1, m is our mean mu, and s is equal to 1, it looks something like this. What happens if I change s? As I increase s, it becomes flatter and flatter because now you have large deviation. If I decrease s, then you see that it becomes narrower and narrower. So s is the spread, right? The standard deviation, and m is changing where the peak is. So if m is 2.5, 2.2, then as you can see, peak is also at 2.2. Okay. If I increase, then it shifts rightwards. If I decrease it, then it shifts leftwards. Okay. So by simple transformation, I can make m is equal to 0. I have to just subtract m from x. Okay. And so if I make it, let's say s is equal to 1, then this is a normal curve. Okay. Increases. So this is called standard normal curve, where mean is 0 and standard deviation is 1. Okay. So you can also play with this with different values. Even for other distributions, you can do the same thing. Okay. So expectation of x is mu, and expectation of x square would be sigma square plus mu square, so that the variance of x is this thing minus expectation square. So mu square gets cancelled and you have sigma square, which means standard deviation, which is the square root of variance, is sigma. Okay, sigma is greater than 0. Mu could be anything. Alright, and what you can do, so this is called normal of x is distributed normally with mean mu and variance sigma square. What you can do is define a new variable z, which is x minus mu divided by sigma. I can do that because we know that function of a random variable is also a function, right? As long as it satisfies certain properties such that piecewise continuous, etc. So this is a very nice linear function, so we don't have to worry about it. And we asked that what is the distribution for this, and turns out that z will follow and with 0 mean and variance 1, right? Why does it happen? Because we know that expectation of ax plus b, expectation itself is linear, so a times expectation of x plus b. In our case, this is 1 by sigma times x minus mu by sigma. Okay, so now if you take expectation, this becomes mu by sigma minus mu by sigma, which is 0. So this turns out to be 0, and variance of ax plus b, that is not linear. In fact, a gets squared, so it becomes a squared times variance of x, and b doesn't have any effect because you are just shifting everything by some unit. So the variance, the spread does not change. Okay, which is why the variance becomes 1 by sigma squared times this variance, which is sigma squared. So you get 0, 1. So this is the standard normal. Okay, so and then that was followed by some problems. So if you had any difficulties in those problems that were solved, you can ask me. Otherwise, we will go to the assignment questions. Any doubts so far? Anyone? You can type in the chat box as well. Okay, then let's go to the assignment problems. Okay, first one is very easy in that it is already given in the notes. So we have a Poissonian distributed random variables. Sorry, we have a random variable which is Poissonian distributed with parameter lambda. We have to tell which statements are true. So the first one is that expectation of x is lambda. Is it true? You can take a look at your notes. Come on, someone answer. Is this true or false? Okay, if you can type in the chat box. Okay, nobody. Fine, then I'll do it myself. But as a punishment, I'm going to solve it entirely. Okay, so we have to find the the expectation of x, which is defined as sum x times f of x, rather p of x, because we have discrete variable. So sum over x is equal to 0 to infinity, because we have Poissonian x, and then px is given by e raised to minus lambda, lambda raised to x by x factorial. And this becomes c raised to minus lambda, lambda raised to x divided by x minus 1 factorial. I cancel this x with 1x here, right, where x is from 0 to infinity. And now I don't really like this x minus 1, so I'm saying that x minus 1 is equal to y, or x is equal to y plus 1. Alright, so now y becomes x minus 1. Yeah, I can use 1 here, because I know that for x is equal to 0, this is already 0. So I can ignore the first term. So I have from 1 to infinity. So now for 1, x is equal to 1, y becomes 1 minus 1. So 0 to infinity, e raised to minus lambda, lambda raised to y plus 1. So I can write lambda raised to y times lambda. This becomes y factorial. I can take out this lambda and e raised to minus lambda out, because it does not have any y, and this becomes lambda raised to y divided by y factorial. Y is equal to 0 to infinity, and this is the definition of e raised to lambda, right? So it gets cancelled with this one, and now we are left with lambda. So the expectation is lambda. That is correct. B is variance. For variance of x, we first need to calculate expectation of x square and then subtract the square of this mean. So this would be given as sum of x squared times px. Px is again e raised to minus lambda, lambda raised to x divided by x factorial. You can do the same thing as previous one. It will be slightly more complicated. In fact, let me just show you. 0 to infinity. Again, 0 can be ignored because we have 0 times something, and that something is not infinity, so we can just ignore that term. So it becomes 1 to infinity, and I can cut out 1x, right? So this becomes x, and divide by x minus 1 factorial, lambda raised to x. Now I have to do this variable transformation. So y becomes x minus 1. So we have y from 0 to infinity, and now we have y plus 1 here, e raised to minus lambda, lambda raised to y plus 1, which I can write like lambda, sorry, divided by y factorial. Now I have to break this y plus 1. So I get sum over y e raised to minus lambda, lambda raised to y, lambda divided by y factorial. So I get just y minus 1 factorial, and this y gets cancelled, plus 1 times this thing. So just e raised to minus lambda, lambda raised to y times lambda divided by y factorial. Okay. And if you do the same thing as previously, we know that except this lambda, it's same as this term. which turned out to be lambda. So this becomes lambda times lambda, and plus this lambda can be taken out, and this also can be taken out, and this is just exponential lambda. So this is just 1 lambda. In other words, this entire thing is lambda square plus lambda, which means variance of x is lambda square plus lambda minus lambda square. So this lambda square and lambda square gets cancelled, and I am left with lambda. Okay. So variance of x is also lambda, which is interesting, right? Expectation and variance both are equal. Alright. The third one, I'll do it here. The moment generating function. Well, that is nothing but expectation of t e raised to tx. So that is e raised to tx times the probability. So sorry, e raised to minus lambda, lambda raised to x divided by x factorial. So I can just take out this e raised to minus lambda outside. So this becomes lambda times e raised to t whole raised to x, right? Divided by x factorial. So e raised to minus t, and now I have something raised to x divided by x factorial. That's the definition of e raised to that thing. So this becomes e raised to whatever is in the bracket, which is lambda times e raised to t. Okay, which is, now I can take out e raised to lambda common. This becomes e raised to t minus 1. So this is the answer, which is exactly what is given. So this is also correct. Finally, fourth one is variance of x is lambda square, but we also already saw that it is lambda. So this is incorrect. Okay, the next one, it's about normal distribution. So we know that normal distribution looks something like this, right? With the mean at x is equal to mu. So 0 could be somewhere here, and the spread is given by sigma, right? The typical spread of the normal distribution. So the first question is that mean is equal to mod is equal to median. So mean is of course mu, we just saw that. Now mod, how do we define mod? We must have learned it in the school, right? Mod is the value which has the highest probability, something that has the most likelihood of happening, which means that fx is highest, which is again at the peak value. All right, so that is also mu. So what we are saying is that the peak value is also the average value, which happens to be the case here because we have a symmetric distribution with a peak at that one. And median, so median is value m such that probability of x less than m is 50%. Okay, so you have 50% chance of being less than m and 50% chance of being greater than m for a continuous one. Okay, in other words, the cumulative distribution function of m should be 0.5. Okay, and we know that this is normal distribution is symmetric about mu, which means that this is 0.5, which means that f of mu is equal to 0.5, which means that mu is also median. Okay, so this is also mu for a normal distribution. Okay, this is not correct for any random, any arbitrary distribution, but for normal distribution this is correct. Okay, second one is we already solved. X follows normal distribution with mean 0, then probability of x less than or equal to 0, that is we are on the left hand side of this mean, that is same as being on the greater side of the mean, on the right side of the mean, and both of them are equal to 50%. right? Because it's symmetric. So this is also correct. C is that it is asymptotic to y-axis. Y-axis is this axis. Clearly, it's not asymptotic, right? It's asymptotic to the x-axis, like it always has to be, at least for the continuous ones. So this is not correct. It should be x-axis here. And the last one is mean is equal to median, but different from mode. But we saw that all three are equal. So this is also not correct. Okay. If you have any doubts or questions, just ask me something if something is unclear. Okay. Third one. Assume that x is a normally distributed with mean mu and variance sigma square. Then we are given a new variable and we have to find the distribution of that. Okay. So we can do two things. First method is that y is ax plus b, then we know that mu of y, or rather expectation of y, is a times expectation of x plus b, which means this is going to be, we have 4x minus 9. So a is equal to 4 and b is equal to minus 9. So this becomes 4 mu minus 9. And the variance of y is given by a square times variance of x. B does not have any effect. So this becomes 16 times variance, which is sigma square. Okay, so the mean is 4 mu minus 9 and variance is sigma square. So it has to be the last one. Alright, but how do we know it's normal? Well, in the options, from the options it's clear. But if we want to solve it rigorously, we can go to the standard distribution. So probability that y is less than or equal to some value y is same as probability that 4x minus 9 is less than or equal to y, which is same as probability that x is less than or equal to y plus 9 divided by 4. Okay, and y, and now I can subtract mu and divide by sigma. So I have to do the same thing here, y plus 9 by 4 minus mu divided by sigma. So this becomes my z, the standard normal distribution, and this, if I rewrite, becomes y plus 9 minus 4 mu divided by 4 sigma. Okay, which I can write as probability that z is less than or equal to y minus mu prime divided by sigma prime, where these are our new expectation and variance, or rather the standard deviation. So I get mu prime is equal to 4 mu minus 9, and sigma prime is equal to 4 sigma. So sigma prime square is equal to 16 sigma square, which means that y is distributed normally with mean 4 mu minus 9 and variance 16 sigma square. Okay, the next one, again I have to repeat, if you have any questions please do ask. If something is unclear, just stop me right away. If I'm not able to hear you, then please type in the chat box. Okay, if you don't ask me, then there is no point. If you don't understand and still don't ask me. Okay, so the fourth one, we are given a random variable with a uniform distribution from -5 to 4, we have to find k such that probability that x greater than k is 1 by 3. Okay, so again there are two methods. So let me just draw f of x first. Our a is minus 5 and b is 4. So this is 0 and it's uniform from minus 5 to 4. Okay, so this is f of x versus x. The height has to be 1 divided by the length, so 1 by 9. Okay, and we are asked, sorry, yeah, what we are asked is that find k, some value k, such that probability of this happening is 1/3, okay, of the whole. So first is because it's uniform, the total length is 9. So probability that we are in this region has to be 1/3 of the whole, which means this length has to be 3, which can only happen if, because this end is at 4, this has to be 1, which means k is equal to 1, yeah, using this common sense. And the second method, which is more rigorous, if you want to say it that way, is that we can explicitly write f of x as 1 over 9. 9 is the length of the interval when x is between minus 5 to 4, and we have to find k such that probability of x greater than k is 1 over 3. And probability of x greater than k is that k to 4 integral of k to 4 fx dx is equal to 1 over 3. So again, this is very trivial, but let me do it for the sake of completeness. K to 4, I can take out 1 by 9 outside. It's just a constant. And so this becomes 4 minus k is equal to 9 by 3, which is 3, which means k is equal to 1 again. Yeah, no surprise. So the answer is k is equal to 1. Fifth one. Now this is interesting. We have two teams playing a series of games, India, Pakistan, let's say. And the first team to win 4 games is declared the overall winner. Alright, so it cannot go over 7 matches. Suppose that one of the team is stronger than the other one and wins the game with probability 0.6. So India has obviously higher chance of winning, 60%, independently of the outcomes of the other games. And what we have to find is that what is the probability that the stronger teams wins the series in exactly 4 games, which means that we have to win 4 games, and we are asked what is the probability that we win in 4 games, which means we have to win each game. Need to win each game, each of the 4 games. And because they are independent, it means that answer should be p times p times p times p. So p raised to 6, where p is the probability of winning. So 0.6 raised to 4, sorry, to the power 4, and 6 raised to 4 is 0.36 square. 36 square is point bar 1296. Okay, so 12.96%. So even though India is a stronger team, there is just around 13% chance that it will win all of the first 4 games, right? Because it has to win each game. Okay. So that's the answer. the sixth one. Now we are given a chair whose lifetime is exponentially distributed, and the mean is given to be 3 years. And we are buying the chair today. What is the probability that it will last for more than 9 years? Okay, so this is has to be very low numbers because on average it lives only for 3 years. But what we are asked is that what is the probability that it will live on for 9 years? So 3 times that mean value. So let's do that. Before that, just looking at the options, these two can't be correct, right? Probability cannot be greater than 1. So it has to be either A or D. Okay. So so this t, the lifetime is given as exponential of 1 over 3, right? Because mean is 1 over lambda. And the question is that what is the probability that t is greater than or equal to 9, which means it's integral from 9 to infinity f of x dx, where f of x is just exponential of lambda. So lambda times e raised to minus lambda x, and lambda is 1 over 3. So e raised to minus x over 3. So this is integral of 1 over 3 e raised to minus x by 3 dx from 9 to infinity. I can take 1 by 3 outside, and integral of exponential of minus x by 3 would be minus 1 over 1 by 3, and then e raised to minus x by 3 from 9 to infinity. This 3 and 3 gets cancelled, so it is minus 1 times, when we put 0, e raised to minus infinity, that's 0, and minus, if we put x is equal to 9, I get e raised to minus 3. Okay, so the answer is e raised to minus 3. Okay, that is the correct answer. And what is happening is that we have an exponential distribution. So this is just a side note. This is fx, and this is our mean, right? This is mu is equal to 1 over lambda. So the probability that you are greater than 0, that is obviously 1. So e raised to 0. Probability that you are greater than this mean, that is given by e raised to minus 1. And let's say this is 2 mu, then probability that you are greater than that value is e raised to minus 2, etc. Right? For 3 mu, it's e raised to minus 3. 4 mu, e raised to minus 4. Right? You can just prove this from these equations. But this is why this happened, because the mean was 3 years. The probability that it will last 3 times that mean, that is why it is exponential of minus 3. Okay, it's the ratio of this 9 and 3. Okay, so now in this one, the moment generating function is given. So f of x is, okay, it's not typed correctly, so I'll just write it down. 1 minus 40 to the power minus 6. This would be not f of x, sorry, but moment generating function. So mx of t. And we are asked to find expectation of x. So if you remember the previous week's content, this is simply given by as derivative of the mx of t evaluated at t is equal to 0. Okay. So if I take derivative of this function, this is minus 6 times 1 by 1 minus 40 raised to 7, and then the derivative of 1 minus 40, which is just minus 4. Okay, so 24 divided by 1 minus 4t raised to 7 at t equal to 0. So this is just 1. So the answer is 24. That is the option B. Alright, the next one. Again, we are given an exponentially distributed variable. We have to find the probability that it is less than 1, not greater than. Less than 1, given that it is less than 2. So we know that it's not going to work for more than 2. What is the probability that it won't work even for less than 1? Okay, so now we cannot use that memoryless Wally formula because that was for probability that x is greater than something. Okay, but nonetheless we can invert this. So we are asked x less than 1 greater, given that x is less than 2. So this is by definition probability that x is less than 1 intersection with probability that x is less than 2 divided by probability that x is less than 2. Okay, now this is where we need to apply some common sense. What we are saying is that x should be less than 1 and less than 2, but if it is less than 1 then it is already less than 2, right? So this is the subset. If you think about this number line, we are asked that what is the probability that we are here as well as here. Okay, which is same as this, because if you think of this as B and A and this as B, then A intersection B is just A. Why? Because A is subset of B. Okay, so this is just probability that x is less than 1 divided by probability that x is less than 2. Now we have to just evaluate this. So this is given by 0 to 1 lambda e raised to minus lambda x dx divided by 0 to 2 lambda e raised to minus lambda x dx. Okay, so if I integrate e raised to minus lambda x, I get e raised to minus lambda x divided by minus lambda, right? So that lambda gets cancelled with this one, so I am just left with e raised to minus lambda x from 0 to 1, actually with a minus sign, and e raised to minus lambda x 0 to 2. So this becomes, I can put 0 first because I have minus sign here. So 1 minus e raised to minus lambda and 1 minus e raised to minus 2 lambda. Okay, and lambda itself is half. So 1 minus e raised to minus half divided by 1 minus e raised to 1. Okay, so that's the correct answer. This is the first option. Alright. Okay, the second last question. A student arrives to the bus stop at 9 a.m. sharp, knowing that the bus will arrive at any moment, which means it's uniformly distributed between 9 and 9:15. Okay, and now it has not arrived for the first 5 minutes. Student is still waiting. Then what's the probability that student has to wait at least 5 more minutes? So let me show it pictorially. This is 9 and this is 9:15. Okay, and we have equal chance of bus coming at any point of time. All right, and so the probability is uniform, so I can write f of x. So let me denote x as number of minutes after 9. So this is x is equal to 0, this is x is equal to 15. So this becomes just 1 by 15, where x is from 0 to 15. Okay, what we are asked to calculate is that what is the probability that the bus will come after 9:10, because he is already there at 9:05. he or she, and but they have to wait at least 5 more minutes, which means it comes after this. The probability of that happening is 1 by third, but it is already given that bus has not arrived by 9:05. So it is given that you are already here. Okay, so we can firstly use just common sense that you have to look at just this region because you are already at 9:05. What is the probability that you have to wait at least this 5 minutes so that the bus comes in this 5 minutes? So that is still equal chance. So you can either be from 5 to 10 or the bus can come from 10 to 15. Both have equal chance. So answer should be 1 by 2. Okay. But formally we can write that probability that x is greater than 10 given that x is greater than 5, right? Because bus hasn't arrived by 5, then we have to find that bus won't arrive by 10 either. And this is equal to probability that x is greater than 10 intersected with x greater than 5 divided by probability that x is greater than 5. Now again, x is greater than 10 implies that x is greater than 5. So if this is A and this is B, then A is subset of B, which means that A intersection B would be the smaller set A. So this is probability that x is greater than 10 divided by probability that x is greater than 5. Okay, and this is given by integral from 10 to 15 fx dx divided by 5 to 15 fx dx, and fx is just 1 over 15. So 1 over 15 times 15 minus 10 and 1 over 15 times 15 minus 5. This is irrelevant, and 15 minus 10 is 5. This is 10. So again we get 1 over 2. This is exactly what we did mentally earlier, right? So the chance that they have to wait at least 5 more minutes is 50%. Okay, the last one, very easy question, that we have a random variable which is given to be binomially distributed with some parameters n and p, and we have to find the expectation of 1 over x plus 1. So we have to find expectation of 1 over x plus 1. Okay, and we know the formula. Expectation of f of x is just sum over f of x. So I shouldn't write f, g of x times f of x, right? So where f of x is the PDF of x, which in our case, because it's binomial, is ncx p raised to x 1 minus p raised to n minus x. Okay, and x is from 0 to infinity, sorry, 0 to n. Why? Because we have binomial distribution. So this becomes sum from 0 to n. G of x is 1 over x plus 1, and f of x is ncx. So let me write it down as n factorial over x factorial n minus x factorial, p raised to x 1 minus p raised to n minus x. Okay, so this is step 1 to actually understand this is concept. Now what follows is just pure algebra, which is also important, but we need to differentiate between two, what is conceptual and what is just manipulation. Okay, so first thing I can do is merge these two. So I get x plus 1 factorial, and this is n minus x factorial. On the upper side I have n factorial, e raised to x 1 minus p raised to n minus x. x is equal to 0 to n. Alright. Now if I can see, sum of these two is actually n plus 1. So if I make somehow on the numerator n plus 1 factorial, then this would be n plus 1 c x plus 1, etc. Okay, so how do I make it n plus 1 here? I multiply by n plus 1 and divide by n plus 1. Okay, so now I have 1 by n plus 1, sum from x is equal to 0 to n plus 1 c x plus 1 p raised to x 1 minus p n minus x. Okay, this is better, but now let me transfer the variable. So y is equal to x plus 1. So y is equal to 1 to n plus 1, n plus 1 cy, and p raised to x is y minus 1. So this becomes p raised to y minus 1. Let me just write like this: 1 minus p n minus y plus 1. And this I can write as p raised to y divided by p. So, and this 1p I take outside, so I get n plus 1 times p, y is equal to 1 to n plus 1, n plus 1 cy, p raised to y, and 1 minus p raised to n plus 1 minus y. Okay, this is good. Now I have to do one thing. What we want is sum over something. It does not matter. Something, choose y, p raised to y, 1 minus p raised to something minus y, where y is from 0 to something. Why? Because this is exactly binomial expansion. So this is p plus 1 minus p whole raised to that something. But it does not matter because this is equal to 1. So this is equal to 1 irrespective of that something star. Okay. So now we can see that something could actually be n plus 1 because we have the same thing here, here, and here. The only hiccup we have is that it starts from 1 instead of 0. Okay, so but I can make it start from 0 by adding and subtracting whatever we want. Okay, so I can write n plus 1 p and then sum starting from 0 to n plus 1, n plus 1 cy p raised to y 1 minus p raised to n plus 1 minus y, and minus the term with y is equal to 0. When y is equal to 0, this becomes something, choose 0, which is 1. This is also 1, and this is equal to 1 minus p raised to n plus 1. So this term we have to subtract. This whole thing, as we saw, is just 1, which means the answer is 1 divided by n plus 1 p times 1 minus p raised to n plus 1. Okay, so let me put a box around this one. This is the answer, which must be one of the options. Okay, it's badly typed, but it's the third one, I believe. Yeah. Okay, so lots of algebra manipulation, etc. But the concept is this, that expectation of a function of random variable can be found just by using PDF of original random variable. So we don't need to find the new random variable or the PDF of that new random variable. That is the concept, and then we have to remember this one trick. Okay, this is the trick. Oh, please explain it again, the question 10. Yeah. So just tell me when you start not understanding. Is this conceptual part clear? How to find the expectation? Uh, just 1 second, I can't hear. Yeah, say it again. Okay. So we have this sum that we have to evaluate. All right. And because we have x plus 1 factorial here, what we observe is that on the bottom, the total is n plus 1. All right. So if I write, let's say mcn, that would be m factorial divided by n factorial and m minus n factorial. If you look it from the opposite direction, I can reduce this to some m choose n only if the sum of these two terms is equal to this one, right? So now I have these two terms, so their sum, which is n plus 1, should be in the upper this numerator, but I have just n factorial. So I need n plus 1 factorial, for which I have to multiply n plus 1, right? So if I multiply that, I have to divide it as well. And because it does not depend on x, I can take it out. Okay. So is this step clear? Okay. So now because the sum of these two is n plus 1 and we have n plus 1 factorial here, I can write it down as n plus 1 cx plus 1. Okay. From 0 to n, whatever is here. And I really don't like x plus 1 because uh, I just want something just y. So I transfer x plus 1 as y. So I define y as x plus 1, same as saying x is equal to y minus 1. So I start y is equal to 1 because when x is equal to 0, x plus 1, which is y, is 1. Okay. So now the index of this summation start from 1 to n plus 1 instead of 0 to n. And I have n plus 1 cy and then p raised to y minus 1 because I replace x with y minus 1, and again same thing here. Okay. Now I want to write n plus 1 cy, so p raised to y and 1 minus p raised to n plus 1 minus y, because then I can use the binomial theorem. But there is y minus 1 here, so I take this p outside. Okay, so I get n plus 1 times p. Now this is exactly the binomial expansion, except that it starts from 1 instead of 0. So I add this term y equal to 0 and then subtract it. So y equal to 0 to n plus 1, subtract y is equal to 0 term. So when you put y is equal to 0 here, you just get this term. Okay. Once you add that term, this is exactly the binomial expansion. So this whole thing is p plus 1 minus p whole raised to n plus 1. And this is just 1. So 1 raised to n plus 1, which is just 1. Okay, okay, which is why we get 1. And finally, we have a very nice expression. Is it clear now? Okay, yeah, summation. Derivative you only do if moment generating function is given. Okay, so when moment generating function is given, if you want to find expectation or variance or anything, you have to find derivative. Okay, yeah. Anyone else? Any other questions? All right. If not, then let's meet next week. That would be 25th February. Goodbye, everyone. Good night.